Today we're going to learn about the magical skill of balancing equations.
Balancing equations is an important skill to know how to do because without it, Cameron would grow a mustache, which would be pretty ugly if you ask me.
Exhibit A. Just kidding! But knowing how to balance equations is an important skill to have, so we are able to identify different compounds and isotopes.
To begin, let's walk through an example, step by step.
We will start off by looking at the equation NO3 reacts with cesium hydroxide.
First, we'll start off by writing out the equation. HNO3 plus CSOH yields H2O plus CsNO3.
Next, we will write out the number of elements on each side in this particular equation. On the left of the equation, we have 2 H's, 1 N, 4 O's, and 1 CS. On the right side of the equation, we have 2 H's, 4 O's, 1 N, and 1 CS.
When listing the number of elements on each side, make sure to list them in the same order on both sides. This will help to keep things simple and a piece of cake.
As you can see, there are some equations like this one that are already balanced. However, sadly, not every equation will be this easy to balance.
Let's take a look at another example. Let's look at the equation. Magnesium nitrate reacts with potassium hydroxide to yield a magnesium hydroxide and potassium nitrate.
Let's begin by writing out the equation. MgNO32 plus KOH yields MgOH2 plus KNO3.
Next, we will list out the number of elements on each side of the equation.
As you can see, this equation is not equal. In other words, it is not balanced. We will start at the top with magnesium. Both of our magnesiums are 1. This means that they are already balanced, so we don't need to worry about them. Our nitrates, however, are not balanced. In order to balance these, we are going to add a 2 in front of potassium nitrate. Unfortunately, this turns our K on our product side into a 2. Therefore, we must balance out our K's. In order to do this, we are going to add a 2 in front of potassium hydroxide. In addition to balancing out our K's, this also balances out our O's and our H's. Our final balanced equation is MgNO32 plus 2KOH yields MgOH2 plus 2KNO3.
And now, Cameron's going to give us a great visual of how to balance equations using socks.
Hey there, sock fans! Alright, today I'm going to show you how to balance an equation using socks. We're going to balance the equation MgNO3, yes, it's that one, MgNO3 2 plus KOH yields MgOH2 plus KNO3. Alright, we're going to start off with MgNO3. Our magnesium is going to be represented by this pink sock. And our nitrates are going to be represented by these long red and gray socks. So we've got 1 magnesium, 2 nitrates. Next, we're going to have KOH. That would be potassium hydroxide. We're going to represent this with a white sock, being potassium, a blue sock, or a small blue sock, being our oxygen, and a long strappy yellow sock, being our hydrogen. Alright, and then on the product side, we've got magnesium hydroxide. So again, pink sock for magnesium. 2 small socks for our oxygen because it is OH2. And 2 long socks for our hydrogen because it is OH2. And then last but not least, KNO3, that is potassium nitrate. Small white sock for potassium. Long red sock for nitrate. Okay, so our magnesiums are already balanced, one on each side, so we're not going to worry about those. However, our potassiums, well, actually our potassiums are balanced, but our nitrates aren't balanced, so we're going to balance those nitrates. So we're going to start on the product side. And on the product side, we're going to add a new... She's laughing at me. We're going to add another nitrate, and I showed you the wrong nitrates. Let's try this. These are the nitrates, and they're not balanced. So on this side, we're going to add another nitrate, but in order to do that, we have to add another potassium. Unfortunately, this unbalances our potassiums. So we've got to rebalance our potassiums by adding another potassium. Voila, balanced potassium. But this unbalances our... Oh, well, our hydroxides were already unbalanced. Adding another potassium means we have to add another hydroxide, which, guess what? Balances our hydroxides. So, our complete... Where did that magnesium come from? Oh, it goes over here. Our complete balanced equation is MgNO3 2 plus 2KOH yields MgOH2 plus 2KNO3.
Now you try. And don't worry, me and Cameron will walk through it with you. Right, Cameron?
Yep. But first you will need a piece of paper and a writing utensil. And your imagination.
But really just a piece of paper and a writing utensil.
Let's try the equation calcium carbonate reacts with HCl to yield calcium chloride and carbon dioxide and water.
Remember, the first step is to write out the equation.
And next, you want to list the number of elements on each side of the equation.
Remember that it should have the same number of elements on both sides of the equation. This will mean that it is balanced.
Well, go on. Get to work.
After balancing the equation, we should have 1 calcium, 2 carbon, 3 oxygen, 2 hydrogen, and 2 chlorine atoms on each side of the equation.
This means that our final balanced magical equation is CaCO3 plus 2HCl yields CaCl2 plus CO2 plus H2O.
Congratulations! You now know how to balance equations like a pro.
Just keep in mind these simple steps and balancing equations will be a breeze.
Thanks for watching.
See you later.